In the previous lesson, I showed you how to use permissions with the DRF. In this lesson, I'm going to show you how to use serializers that are not associated with a Django model. Up until now, all of the serialization that I've shown you has been associated with a Django database ORM object. You don't have to do that. You can create a serializer from scratch, and it doesn't have to serialize something from Django. You do this by inheriting from the serializers.serializer class and combine it with serializer fields. Serializer fields are similar to Django model fields. You can explicitly create a serializer specifying field by field. It doesn't have to be based on that ORM. In this lesson and the next lesson, I'm going to use the same app, which is a new one called Vehicles. Like always, if you're coding along with me, you'll need to add vehicles to your installed apps list. You'll need to update your URLs file to include vehicle.urls to pull in anything defined there. And then follow along with any models, serializers, views, and URLs that I show you. For this particular lesson, there won't be anything to migrate. I'm going to create stuff inside of the models space, but it is not going to be Django objects, so you won't have to do the make migration and migrate. Because I'm going to be using the same vehicles app in this lesson and in the next lesson, and I'm going to be creating multiple models, in order to be a little more organized, I'm going to switch over from using a models.py file to a models directory. If you haven't seen this before inside of Django, the mechanism's more or less the same. Instead of creating the models.py file, you create a directory and then create files inside of it. There's one extra step that you have to do to get all this to work, which I'll show you in a second. Inside of the models directory, I've created a file called tools.py, and inside of that, I'm creating a regular old Python object. This object has a couple of attributes, one called name, the other called make, and all I'm doing inside of the initialization is assigning those to the object. So that that file I just created can be read from the models as a module, I've had to create a _init file, and I'm going to import that tool object inside of it. Now for the serializer. In order to keep the code nice and clean, I'm going to use a serializers directory similar to the models directory. And so inside of the serializers directory, I'm going to create tools.py, which corresponds to the tools.py file inside of the models directory. Here's my generic serializer. Notice that it's inheriting from just serializer instead of model serializer. I'm specifying each of the fields that I'm going to serialize, and I specify one field for each of the attributes of the tool object. Both of these are char fields, which, similar to Django model char fields, contain text and have a max length in this case of 50. Continuing on with the pattern, I've created a views directory, and inside of that, I've created tools.py. For tools, I'm creating a single view that just lists the tools to give you the idea of how this serialization works. On line 8, I'm using the API view decorator in the exact same way as one of the early lessons. And line 9, I'm creating the definition of the list tools view. Line 10 through 13, I'm creating two tool objects. These are just generic Python classes that have been instantiated as hammer and wrench. From line 15 on, this method is no different than when it is a Django object being serialized. You create the serializer, you pass in the thing being serialized, in this case a list of the tool objects. Because it's multiple objects, I'm setting many set to true. And then I create a content dictionary that consists of the serialized data and pass it into a REST response object. Finally, to make it accessible, I need to add list tools as a path, pointing it to the view. To demonstrate this view, I'm going to use the browser and point it at the web interface. Going to the list tools view that I just created. And like before, you get back the same kind of interface showing the serialized data. You can serialize anything you like. It doesn't have to be a Django object. This gives you a fair amount of power. You can serialize the things in your database, or if you want, you can create your own as needed by your application. In the sample code, I showed you how to use the char fields. There are a large number of fields provided by the DRF. There are fields for Boolean, A long list of string fields. Most of these are similar. What changes is the validation. So for example, the IP address field is still just a string, but the validator makes sure that the string is formatted as a valid IP address. There are 3 numeric fields for date and time, and 2 fields that allow choices of predetermined selections. There are fields for uploaded files, composite fields, which hold groupings of other things like dictionaries or nested JSON, and specialty fields like read-only and hidden for your forms, or the serializer method field, which is a special field that is read-only that gets mapped to a method inside of the serializer. Every time the field is serialized, that method gets called, which allows you to run arbitrary code anytime serialization happens. If all of that's not enough, you can always write your own. But before you do, you should check out whether or not what you are trying to dream up has already been done for you by someone else. There are plenty of third-party libraries out there that contain other kinds of fields that you might find useful. When you instantiate a field, you can pass it arguments to control how it behaves. Some of the arguments are whether or not the field is read-only, write-only, required, what its default value is, whether it allows null, what the source attribute of the field is. By default, the serializer class uses the name of the field to look up the corresponding field in the object being serialized. If you need to rename this, or there's a reason that mapping won't work for you, the source argument allows you to specify where to look something up. You can specify validators, similar to Django's model validators, that determine whether or not the values in the field being serialized are valid. And then finally, error messages, label, help text, initial, and style are all arguments you can use to specify the presentation. Some of these are specific to certain kinds of renderers. For example, if you were using the HTML renderer, the style argument can pass in CSS information to tell the template how to style the field being rendered. As you've probably surmised, the model serializer that I've been using up until now is built based on top of all these concepts that are already here. The serializer is the beating heart of the DRF. It's all about how you get that payload and how you use it. For more information on how fields work and how to use the arguments that go with them, see the Fields section of the API guide. So I've shown you how to serialize things and how to specify specialty fields. In the next lesson, I'll show you how to do nested Django ORM objects. In the previous lesson, I showed you how to use a serializer with a plain Python object. In this lesson, I'm going to show you how to deal with related objects and nested serialization. The DRF provides ways to serialize related objects in your ORM. Objects that refer to each other by foreign keys can be identified by an ID. You can also nest serialization by having related objects contained within one another. This time around, I'm going to continue using the Vehicles app from the previous lesson. You can follow along with the new models, serializers, views, and URLs files as shown. If you desire, you can create an admin.py file to go along with the models that are there, or use the one in the supplementary materials. Don't forget to run make migrations and migrate as necessary to get your models into the database. And of course, you'll want some data to play with. You can either use the admin or the load data command with one of the fixtures in the supplemental materials. Like in the previous lesson, I'm going to use the models directory and create a file called vehicles inside of it. The vehicles models file contains 2 Django definitions, one for a vehicle that has a single field name, and one for a part that is related to the vehicle. Each part has a name and a make, and has a foreign key onto the vehicle, so there will be multiple parts in the vehicle. Because I'm using the models directory, I need to update the dunder init file in order to import the vehicle and part so that Python can find these objects. And here's the serializers file. First off, I want to serialize the vehicle. Except for line 18, everything here is what you've seen before. The vehicle serializer inherits from the model serializer. On line 21, you indicate that this is serializing a vehicle object. On line 22, you list those fields that you're interested in. Line 18 is what's different here. I want to nest the part objects inside of the vehicle object, and in order to do that, I'm going to add a new field called the part serializer. Because vehicles are related to parts through a part set, the field name here is part set. This allows REST to automatically run the query that relates the vehicle to the part. Because there could be multiple parts for each vehicle, I'm setting many to true, and in this case, I'm going to set read-only to true as well. The reason you do this is so that if you create a new vehicle, you don't have to specify the parts that go with it. You can just create the vehicle on its own. You can decide for yourself, based on your construction, whether you want to create things like parts separately from the vehicles or do it with a post containing a nested object. The part serializer is similar to what you've seen before. It's based on model serializer, the meta information points it at the Django part module, and the fields listing lists those fields that are going to be included in the part. Additionally, I've added another field here, which is a custom field called serial number field. The serial number field is going to create a custom serial number based on other attributes of the part. Notice that I'm using the source argument for the serial number field. Normally, the DRF looks for the name of the field and uses that to look up the related value inside of the object. The part object has no field named serial number, so the DRF has no way of looking it up. The argument to source maps this lookup. If I wanted to point this at an existing field inside of the part, I could set the value of source to that field. By setting it to asterisk, it tells the DRF to just use the field serializer and set the value to whatever the custom field returns. And finally, to tie it all together, here's the serial number field. This is a custom field that inherits from the serializer's field object and implements the toRepresentation method. When called, the representation takes a value of the thing being serialized, which in this case will be the parent, the part, and then lines 7 and 8 take information of that part and return a string, which in this case is based on part of the make field and the ID of the part. Each part that is serialized will include a serial number field. Each of those fields will call toRepresentation. The make and the ID of the part will be combined into a serial number and returned into the serialized object. Now to create some views for the vehicle and part objects. Like before, I'm creating the vehicles.py file inside of the views directory. Line 12 declares the vehicle view set. Line 8 declares the part view set. Both of these specify the serializer that they're associated with, and the only thing I've done a little different here is shown you a shortcut for creating your query set. Line 15 and 16 you've seen before, which is implementing the getQuerySet method of the vehicle view set. It returns all vehicles. Alternatively, you can do the same thing by setting the querySet attribute like I've done in line 10. If your query set is simple, like all objects, the querySet attribute is the better way to do this. If determining your query set is more complicated, like I showed you when filtering the restricted values of books with Indie, then you'll need to use the getQuerySet method instead. Here's the vehicle's URLs file. I'm creating a new router, registering the vehicle view set and the part view set, and then including that on line 12 in my URLs path. Here I am in the browser. I'm going to visit the vehicle's URL. This time I've done something that I haven't done in a while. I'm visiting the vehicle's base URL. Because the router has registered multiple URLs inside of it, when you hit the base URL, the router shows you all of the possible children. This is a convenient way of getting meta information about what your interface provides. Unfortunately, it only works with the router, so the list tools method that I created in the previous lesson doesn't show up here. It's still there, it just doesn't show up in this listing. But for those things that are created with a router, you can do this automatically. This in and of itself is an argument for always using view sets and using your router so that you can take advantage of this meta information. I'm going to click on the parts listing, and here you have the data that I loaded before, 2 parts. If you were paying close attention when I showed you the serializers, you would have seen that I didn't include the ID field this time. I include URL. What's URL? URL is a special DRF field that returns the URL that specifies the object. This is actually a better alternative to using the ID. If you have queried this and you have the URL available, you can use that URL to do patches or puts or deletes afterwards. This means you don't have to hard code the URLs for your objects inside of your application. This is definitely a better way to go. There are a couple situations here which you have to do some extra work to get this URL, but in the vanilla mechanism that I've just shown you here, it more or less comes for free. I'll show you the exceptions in the next lesson. Because I'm in the web browser, I can just click straight on one of these URLs, and now I can see the detail information for the part that is in the database. I'm going to go back out to the API route, and now I'm going to click on the vehicles URL. Let me just scroll down here a little bit so you can see all of this. The payload for the vehicles URL contains one vehicle, which is the U26 Werfler, and that vehicle contains a part set. The part set is an array containing all of the parts that are associated with that vehicle. This is nested serialization. This is another good reason to use the URLs when you're referencing these objects. Now you've got both the vehicle and the part information available to you in the payload. If you want to change the vehicle, you can use the vehicle's URL, and if you want to change the part, you can use the part's URL. That's how you do nested serialization. In the next lesson, I'm going to dig more into views and view sets and how you can specify more actions over and above the standard HTTP methods.